Hi, and welcome to Mr. Garofalo's podcast. In this episode, we'll be looking at the trigonometry of the right triangle. And today we're going to look at example 4 and 5 from your notes packet. These examples were a little bit rushed at the end of class, and I'd like to go through them in a little bit further detail for you so I can best support you on your homework. So today we learned a helpful mnemonic to help us remember the ratios. The mnemonic device is SO, CA, TOA. And as a reminder about what that means, the SO it stands for the sine of an angle, which is the ratio of the leg opposite the angle to the hypotenuse. The CA stands for cosine of an angle, which is the ratio of the leg adjacent to that angle compared to the hypotenuse. And then the TOA is for tangent, which is the ratio of the leg opposite the angle compared to the leg that's adjacent to the angle. So in example 4, we're given ratios for certain angles, but we're not told which ratio it is. So in 4a, we're told that the ratio for angle E is 8 to 10. So the first thing I want to do is go into my diagram, and I see triangle DEF here, which has measurements of a leg of 6, a leg of 8, and hypotenuse of 10. And if you kind of have to picture yourself actually standing in the triangle and think about where the legs and hypotenuse are in relation to where you are in the diagram. And I like to use arrows to help me out with this. So what I would do is if I'm at angle E, the side across from angle E is side DF. So this would be opposite angle E. We know that the hypotenuse is always opposite the right angle, and it's always the longest side, so it had to be 10. And then the adjacent side to angle E would be side DE, which is 6 units. So we have adjacent, opposite, and hypotenuse labeled. This is all in reference to angle E. So what I could do is do all the problems that have angle E in them using these labels. So 8, if I angle E and I find 8, I see 8 is opposite, so 8 is opposite, and 10 is the hypotenuse. And in the ratio that uses opposite compared to hypotenuse is the first one. It's the sine ratio. So we can say that the sine of angle E is 8 to 10. So I'm going to write SIN, abbreviation for sine. The next one with E is C, and that is 6 to 10. So if I find angle E and I find 6, I see that's adjacent, and 10 is the hypotenuse. So this is comparing the adjacent leg to the hypotenuse. And the ratio that does that is cosine. And the abbreviation for cosine is COS. And then in E, we have a ratio of 8 to 6. And if I go to angle E, I see 8 is opposite, and 6 is adjacent. So we're comparing opposite over adjacent, and that's the tangent ratio, TOA. And the abbreviation for tangent is TAN. Remember, tangent is the only ratio that can be greater than 1 because you're comparing the two legs, and one of the legs can be larger than the other. However, in sine and cosine, since the denominator is always the hypotenuse, you cannot have a number greater than 1 since no leg can be greater than the hypotenuse. So now I'm going to take these labels away because we're going to reference a different angle for the next set of problems. The next set of problems, we're referencing angle F. So this is more similar to what you did in your measuring triangles activity. This would be like the base angle, where DE is the height and DF is the base. I'm going to make the same labels I made before. So the first thing I'll do is I'll go opposite angle F, and I find that side DE now is the opposite side, the opposite leg from angle F. The hypotenuse, of course, is still side EF, 10. But now the adjacent leg is DF, which is 8 units. So now I can make my other ratios. 6 to 8 would use opposite over adjacent. That's tangent. So B is asking for the tangent of F. In D, we're using 6 compared to 10. So that's opposite compared to hypotenuse. That's the sine of an angle. And then in F, we're using 8 compared to 10. That's adjacent compared to hypotenuse. That's the cosine of an angle. So we've now correctly identified which ratios were being used as a result of these values. In example 5, we're not given the ratios, but we're asked to find the sine, cosine, and tangent of angle R and angle S. The first one we're asked for is, and we're asked to do it in lowest terms. So we're going to look at how that would work. And this right triangle, RQS, has a leg of 4, another leg of 4 radical 3, and a hypotenuse of 8. Remember, these are right triangles, so these lengths do have to satisfy the Pythagorean theorems. They cannot be arbitrary numbers that are made up. If you plugged in these two legs and squared them and added them together, they would equal the square of 8, which is 64. So for the sine of R, it might be helpful to write SOHCAHTOA at the top of this problem to help you remember the ratios. So for sine, we're using opposite over hypotenuse. I'm going to find the angle they're referencing, which is angle R. And if I go opposite angle R, find the length of leg QS is 4 radical 3, and the hypotenuse of this triangle RS is 8. So this is 4 radical 3 over 8. This can be reduced to lowest terms because 4 over 8 can be simplified to 1 over 2. So this is really radical 3 over 2 in simplest terms. In A, we're asked for the cosine of R. I'm going to take away these labels, and I'm going to go to R, but now I'm going to look for the adjacent compared to the hypotenuse. Well, the leg that's adjacent to R is RQ, which is 4 units. So this would be 4, and the hypotenuse is 8. 4/8 would be 1/2, or you can write 0.5. And lastly, the tangent of R would be opposite over adjacent. So the side opposite, once again, is QS, 4 radical 3. The adjacent side to angle R is RQ, which is 4. And again, we can reduce to lowest terms. 4 over 4 would divide out to 1, so we're left with just radical 3. So there are the sine, cosine, and tangent ratios for triangle RQS. If you use this strategy of writing in the diagram and writing out the ratios for the sides that you need, I think you'll find some success. Should you have any difficulties, email me this weekend. I'll be sure to get back to you. Good luck, and see you in class.